Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 4 of a unit work, power and energy. Let's begin with today's class. In today's class, we are going to discuss about the work energy theorem and its applications. So let's begin with the work energy theorem and its applications. In first, we are just have quickly revise this. What is work energy theorem? And then we will switch to its application. So according to the work energy theorem, total work done, that should be is equals to change in kinetic energy. While I say total work done, we have already discussed this is one more time that I need to consider work done due to first force plus work done due to second force plus work done due to third force up to work done due to n force. That should be is equals to change in kinetic energy, that means half mv square minus half mu square. While I say work done due to first, I should understood it's an F1 delta x1 plus F2 delta x2 plus F3 delta x3 up to Fn delta xn. That should be is equals to half mv square minus of half mu square. This is change in kinetic energy. While doing so, we consider that all forces such as external, internal, conservative or non-conservative can change the kinetic energy of the system. So we have discussed up till now, and then we have discussed the applications. I hope these things are clear. Yes, that when I need to have a question, what I'm supposed to do is I will find out all the forces that are acting on my system. I will find out the work done due to each and every individual force. After having work done due to all the forces, I would equate that total work done with the change in kinetic energy. That's it. That is what I need to do it. I hope this is clear. Is it clear? Is it great? So let's work for the new question. Let's have a look. Suppose this is a block having mass m and it has been tied up at a rigid support, and this rigid support, this is in lift, and that lift is moving upward with acceleration of g by 2. Yes, initially it is at rest. Let's have a work that if a given system is at rest initially, find out velocity of block M when it has shifted for h meter. Yes, we need to find out the velocity of block M when it has shifted for the h meter. So what I need to do is, first let's have a look. This is the T, one more force, it's an mg, and it is moving upward, so it's a g by 2 acceleration. So first I'm interested to get tension force. So this is T minus mg, that should be is equals to ma, and here they have given that A is equals to G by 2. So T is equals to mg plus m into G by 2. This is equals to 3 by 2 mg. This is the tension force. This is the tension force. This T is equals to 3 by 2 mg. Is it clear? Is it? Great. So this tension is equals to 3 by 2 mg. Now what I need to do is that one more force is the mg. So force due to gravity, that should be is equals to mg. Now I need to find out the work done due to this two forces. That first is the work done. This is the situation that here tension would be there, here mg would be there. Then the work done due to tension force is tension force multiplied by displacement. It is 3 by 2 mg into h. Now work done due to mg force, it's an mg into h. But if tension is taken in the upward direction, then this would be a cos of 0 degree, and that would be multiplied by 1. This is in the negative x direction, but my block has been shifted in the upward direction with a height of h. It's an mgh into cos of 180 degree. That would be equals to minus of mgh. I hope this is clear. Now it says that it is initially at rest. If a given system is at rest initially, so work done, or I should say total work done, should be equals to change in kinetic energy. This is 3 by 2 mgh minus of mgh should be equals to half mv square. Yes, initially it was at rest, so nothing to be considered. So this is 3 by 2 mgh minus mgh. That could be written as mgh by 2 should be equals to half into m into v square. This mass could gone, this 2 got gone, and v should be root of gh. That's it. You did it. Is it clear? Is it? So can you do this? Can you? I hope this is clear. Is it? Is it? Great. So I hope now you will be able to solve this kind of questions very easily. Yes. Now let's look another category of questions based on this principles only. Let's assume that if car and truck are having same kinetic energy, if they have been applied same retarding force find out ratio of their stopping distance. So look at this question, very interesting. It says that if car and truck are having same kinetic energy, that means they may be moving and they are having the same kinetic energy. Now if they have been applied a same retarding force, find out ratio of their stopping distances. As I understand, let's suppose understood the mass of the car m1. Let's assume mass of the 2, it's an m2, it's the mass of the truck. While I understood it's a car, it's a truck, that means I must understand that m2 would be, for obvious, it is a greater than m1. Yes, truck is having a higher amount of mass as compared to the car. So how could I do this? So that I can have the ratio of their stopping distances? Any idea? Anything? Anything? How should I do this? How should I? So let's work on it. I understood that work done on first divided by work done on second should be is equals to force 1 multiplied by displacement 1 divided by force 2 multiplied by displacement 2. That should be is equals to work done can also be considered as a change in kinetic energy of first divided by change in kinetic energy of 2. I hope this is clear. Now as they have applied that they have been applied same retarding force. So F1 equals to F2. So that's a delta x1 stopping distance of first divided by stopping distance of second. That should be equals to delta Ke1, it's an half mv square minus of half mu square. This is true for the first object, and delta Ke2, it's an half mv square minus of half mu square. This is true for the second object. Yes, these are the stopping distance. This is the stopping distance. This is the stopping distance of car to this is the stopping distance of truck. Yes. So if you understood that finally they came to rest, so their final energy would be 0 and their initial kinetic energy was the same. It's a kinetic energy of 1 and kinetic energy of 2, and they mention over the data that kinetic energy of 1 and kinetic energy of 2 would be equal. So this is the 1:1. This is stopping distance of car. This is stopping distance of truck. They are in the ratio of 1:1. So if they are having same kinetic energy, if they are having the same kinetic energy and they have been gone through the same retarding force, their stopping distance are equal, or the ratio of the stopping distance is 1:1. I hope this is clear. Is it clear? What was your answer? What was your answer? Do you land on the same location? Yes? Great. Now, shall I add something? Question. In the previous question, find out ratio of their stopping time. Yes, I need to find out the ratio of the stopping time. How should I do this? How could I? Yes, what is given? The given data is that force 1 and force 2, that means retarding force, are the same. Their kinetic energies are same. Yes, kinetic energy 1 and kinetic energy 2. So even they are going to stop. So even change in kinetic energies are same. Yes, it's a delta Ke1 equals to delta Ke2. Even this would be the equal. What I need to do, I need to find out the T1 is to T2. How should I do this? How could I? So what I understand is kinetic energy is equals to P square by 2m, and what I understood next, it's a F is equals to delta P by delta T. F is equals to delta P by delta T. So now let's start doing that. Work done 1 is to work done 2. That should be is equals to F1 x1 divided by F2 x2. That should be is equals to change in kinetic energy 1 divided by change in kinetic energy 2. I hope this is clear. Is it clear? Is it? Great. So Now what we can do is I can replace the force. I can replace the force with the help of delta P by delta T. So let's trying to do this. It's a F1, it's a delta P1 divided by delta T1 multiplied by x1. For F2, it's a delta P2 multiplied by delta T2 divided by x2, and this is equals to change in kinetic energy 1 divided by change in kinetic energy 2. Is it clear? Is it? Yes. Now in the previous example we have proved it that the stopping distances would be equals to x1 equals to x2, so I can cancel it out. So I have been left with the delta P1 divided by delta T1 multiplied by delta P2 divided by delta T2. It's their stopping time. Now kinetic energy. What can I write for them? So I can have that relation that kinetic energy is equals to P square by 2m. Yes, kinetic energy can be written as P square by 2m. So this is, let's write it down at this point of time. It's a delta K1 divided by delta K2. I hope this is clear. Yes. So it is just that delta P1 divided by delta P2 multiplied by delta T2 divided by delta T1, that should be is equals to change in kinetic energy 1 divided by change in kinetic energy 2. As again, according to the data, change in kinetic energy 1 and change in kinetic energy 2, these two are the equal. So what I can have, it's a delta P1 is to delta P2, that should be is equals to P1 is to P2, it's a delta T1, it's to delta T2. This is where we are interested. Now momentum, what we can say about the momentum, we can have this relation kinetic energy is equals to P square by 2m. So I can easily write P should be equals to root of kinetic energy into 2m. So this is P1, that I can write, it's a kinetic energy of 1 multiplied by 2 multiplied by m1 divide by this is root of kinetic energy of 2 multiplied by 2 multiplied by m2, that should be delta T1 divided by delta T2. What data says? Data says these two are equal. This has gone, this has gone, this could be gone, this could be gone. So their stopping distance delta T1 divided by delta T2 are the proportional to the square root of their masses. It's an m1 is to m2. I can say so, it's a stopping distance which is directly proportional to the root of mass. That means higher the mass, higher the stopping time. That means truck will take more time to stop than car if kinetic energies are same. I hope this is clear. So this can be proved easily. Yes, I hope this is clear. Yes, and these are very interesting questions, because at our first time when they said that kinetic energies are equal, their retarding force would be the same, find out the ratio of their stopping distance. According to our first sense, we are not ready to accept that the stopping distances could be equal. Yes, because we understood that no, car would be having more stopping distance and truck would be having less stopping distance, or something like this. Yes, so this can be proved mathematically, and when it can be proved mathematically, we must understand that yes, this is the real scenario. I hope this is clear. Yes, do you find it interesting? Let's have some more question based on this principle only. Yes, if truck and car are moving with same momentum, and they have been passed through same retarding force, same retarding force, so they come to rest. Now find out ratios of first their stopping distance, and the second their stopping time. So let's have a look. They have given that truck is there, car is there. This both are moving with same momentum. This both are moving with the same momentum, and they have been passed through the same retarding force. So they were again reaches to the rest. Find out the ratios. Find out the ratios of their stopping distance and their stopping time. So first let's work for the stopping distance. What all things I have given. Mass 1, it is car. Mass 2, it is truck. Their momentum are same. Yes, so P1 equals to P2. The applied force are the same. F1 is equals to F2. So how should I do this? Let's work for the stopping distance first. First ratio of their stopping distance. So now let's write down their work done. Work done 1 is to work done 2. This is equals to F1 x1 divided by F2 x2. That should be equals to change in kinetic energy of 1 divided by change in kinetic energy of 2. But now kinetic energies are not same, momentum is the same. So I can replace the kinetic energy with the help of P square by 2m. So this is P1 square divided by 2m1 multiplied by P2 square multiplied by 2m2. I hope this is clear. Is it clear? Is it? Are you sure? Great. Now according to the data, as per data, F1 equals to F2, same retarding force, and even the momentum are the same. So if I take a ratio of this two, it's an F1 x1 divided by F2 x2. That should be is equals to this 2 has gone, P1 square divided by P2 square multiplied by M2 is to M1. This retarding forces are same. This 2 has cancelled. This is the stopping distance. As momentum are equal, even this 2 would be the cancel. So we can have x1 is to x2. That should be M2 is to M1. That means stopping distance is inversely proportional to the mass. So stopping distance of truck would be less. Stopping distance of truck will be less than stopping distance of car. I hope this is clear. So stopping distance of truck will be less than the stopping distance of car. Yes, when this is the case when momentums are equal. Is it clear? Is it? Are you sure? Done? Great. Now let's find out the ratio of their stopping time. Ratio of their stopping time. So now I want to find out the ratio of the stopping time. So how should I do this? How should I do this? I know that force is equals to delta P by delta T. So let's just write down, it's an F1 is to F2. That should be delta P1 divided by delta T1 multiplied by delta P2 divided by delta T2. Now according to the data, the retarding forces are equal, momentum are equal. Yes, so as F1 is to F2, it's a 1 delta P1 divided by delta P2 multiplied by delta T2 divided by delta T1. So this is 1, that should be equals to 1 into delta T2 divided by delta T1, because even the momentum is same. So it's a delta T2 should be equals to delta T1. So in this case, the stopping time will be equal if their momentum is same. Yes, so this is very surprising that if momentum is same, their stopping time is same, and if momentum is same, their stopping distance could not be same. It is the inverse ratio of their masses. And when we used to have to do this same question when kinetic energies were same, look at this. So the stopping time is directly proportional to the square root of the mass. That means the higher the mass, higher the stopping time. But their stopping distances are equal. Look at this. Stopping distance of truck is equals to stopping distance of car and onwards. I hope this is clear. Yes, this seems very easy, that I can find it out easily. But I'm sure that other than this option, maybe not landing on this correct answer. Yes, so it is very easy to look at this question and try doing it. But once we are having the incorrect answer, we have not any option. To do this. I hope this is clear. So please use this kind of tactics to do this kind of questions. I hope this is clear. Is it? Great. Now let's look at the next application. It says that a bullet of mass m is moving with velocity v, stops in a wooden block after penetrating through a distance x. Okay. If F is the resistance offered by the block to the bullet. So what I understand is that at this point of time it is having certain velocity. And finally it comes to rest. So you need to find out the resistance offered by the block to the bullet. So work done due to friction, it's a minus of Fx into k. Final energy, it's a 0 as it comes to rest. So this is 0 minus of half mv square. And so that you can have the force of friction is equals to half mv square by x. Yes, it is as simple as that. I hope these things are clear. Is it clear? Is it? So will you be ready to do this kind of questions? Will you be? Let's have a look. Let's assume that this is a wooden block. Your object, that is, let's say bullet, having mass of something and reaches here with certain velocity v, has traveled a distance. has traveled a distance of 30 meter. It's traveled a distance of 30 meter and come to a rest. It's a v equals to 0. Yes. So let's have a look. A bullet having mass of 20 gram and velocity of 500 meter per second comes to rest after penetrating wooden block floor 30 meter. Find out frictional force. Find out frictional force provided by wooden block. So how will you do this? How will you do this? So what I can have is that work done due to all the forces. It's a total work done. That should be is equals to change in kinetic energy. The total work done should be equals to change in kinetic energy. So here only one of the forces is acting, and that is the resistive force by the wooden block. So what I can have, it's the friction multiplied by distance x. That should be equals to half mv square minus of half mu square. Yes. So this is the f multiplied by friction distance, that is of 30. That should be equals to half multiplied by mass. Mass is of 20 gram. That's 20 divided by 1000 multiplied by, initial velocity is 0. So it is, this should be a 0. 0 minus of half multiplied by 20 divided by 1000 multiplied by u square. This is 500 square. It's a 5 square multiplied by 10 to the power 4. So this is equals to f into 30 is equals to minus of 1 by 2 multiplied by 20 divided by 1000 multiplied by 5 square. It's a 25 into 10 to the power 4. So let's just try to get it done. So here it was minus of 1 by 2 multiplied by 2 into 10 to the power 3 into 10 to the power 2 multiplied by 25 divided by 1000. Yes, this 10 to the power 3, this 10 to the power 3 has gone. This 2 has gone. This is 25 into 10 square. This is, so 25 into 100. This is 2500. So this is f into 30 is equals to 2500. So this force of friction again in the minus, because this is negative work done. It's a minus of 2500 divided by 30. This has gone, and this is 250 by 3. It is approximately 83 point something. Yes, because 83s are 240 and the remaining 10 has been left. Yes, it's an 83 point something Newton. Yes, this negative sign represent that force of friction opposes the motion of a bullet in the wooden block. I hope this is clear. Is it clear? Is it clear? Is it? Great. So, will you able to do this kind of questions? Will you be? Are you sure? Great. Let's move to the next question very quickly. You are doing good. Yes, well done. keep this continue. Let's suppose if it is given that if a force of F is equals to, let's say, 2x plus 3 Newton acts on a particle of mass 2 kg initially at rest. If force of F is equals to 2x plus 3 Newton acts on a particle of mass 2 kg which is initially at rest, applied up to its displacement by 5 meter. Find its velocity when it has been displaced by 5 meter. So you need to do this. Force is given, mass of a particle is given, even that is given that it is initially at rest, and this force make sure that this particle has been displaced by 5 meter. I need to find out its velocity when it has reached by, or when it has been displaced by 5 meter. So what I need to do is, what I understand is that work done is equals to change in kinetic energy. Now in this situation the force is the variable, and as the force is variable, what I need to do is I need to use an integration to get it done. So this is integration of f dot dx, that should be is equals to change in kinetic energy. Let's just do it. That this is integration of 2x plus 3, that should be equals to half mv square minus of half mu square. They have mentioned that it is initially at rest, so this term, this complete would be a 0, so it has been left with the half mv square. This is from 0 to 5, so this is 2x, it's a 2x square by 2 plus 3x, this is from 0 to 5, so this is x square plus 3x from 0 to 5, that should be equals to half into m into v square. So this is 5 square plus 3 into 5 should be equals to half into mass. The mass is of 2 kg multiplied by velocity square. This has gone. It's a 5 square, it's a 25 plus 15 should be equals to v square. So this v square should be equals to 40, or I should say v should be is equals to it's a root of 40 meter per second. I hope this is clear. Is it clear? Is it clear? Is it? Are you sure? Are you sure? Great. So this would be the answer. Now let's work for the next and last question of this lecture. Let's do it quickly. It says that kinetic energy of a particle moving along a circle of radius r, depends on the distance covered, x, as kinetic energy is equals to alpha into x square where alpha is a constant. What do you need to find out? Find out force acting. Find out the force acting on a particle. Yes, that is sure that it will be there in terms of the x. So what you should do, take your time, take your time of 30 seconds and just try to do it. Yes, what you will do, how can I do this? So first thing what I need to consider is that this is kinetic energy and this is equals to alpha x square. So as I consider that this is case of non-uniform circular motion, this is case of non-uniform circular motion, how could I came to a conclusion? Because this is kinetic energy, this kinetic energy is equals to half mv square, and that would be equals to alpha x square. X is the distance, and as x is changing, velocity would definitely changing because mass cannot change and alpha is the constant that has been given. So if velocity is changing, that means it is a non-uniform circular motion. So your question would be F net, and while calculating F net, I should keep in mind that I need to find out Fc, which should be is equals to mv square by r. I need to find out Ft, which should be equals to m dv by dt. This is tangential force, this is centripetal force. So this is my guideline that I need to follow this, and I need to find out this to get my answer. I hope this is clear. So let's begin. We have the relation, it's in kinetic energy is equals to, this kinetic energy is equals to alpha into x square, and kinetic energy can be written as it should be equals to 1 by 2 mv square should be equals to alpha into x square. So from this we can have it's a v square should be equals to 2 alpha x square divided by m. Let's differentiate it with respect to time. So it's a d by dt of v square should be equals to d by dt of 2 alpha by m into x square. Yes, so d by dt of v square, it's a 2v multiplied by dv by dt. This is 2v dv by dt, that should be equals to 2 alpha by m, as it is a constant. D by dt of x square, it's a 2x into dx by dt. So now what I can write, it's a, I can understood that this dx by dt, this can be replaced as v, this can be replaced as v. So we can have that it's a 2 into v multiplied by dv by dt, that should be is equals to, this is 2 alpha by m, this is 2 alpha by m multiplied by 2x multiplied by v. I hope this is clear. Is it clear? Is it? So we can, if I solve this, it's this 2 and this 2 could gone, this velocity could gone. So I have been left with the dv by dt, which should be is equals to 2 alpha x divided by m. This is the dv by dt. Now what I want, it's an f tangential, it's an m multiplied by dv by dt. So that could be written as m multiplied by dv by dt. This dv by dt could be 2 alpha x divided by m. This is the dv by dt. This 2 could be gone, and that could be written as 2 alpha x. So I have done one of the tasks, that I have find out the tangential force. Now it's a time for the radial acceleration on the radial force Fc. That would be equals to m into AC, or I should write it as an m into v square by r. So mv square by r, mv square by r. How could I do this? Look at this. Initially this should be came in back of your mind. Kinetic energy was given, that is of alpha x square. This is half mv square, that should be equals to alpha x square. So mv square is equals to 2 alpha x square. Mv square, that should be equals to 2 alpha x square. It's a 2 alpha x square divided by r. I hope this is clear. So this is Fc. I am already find out the Ft, and which was 2 alpha x. So Fnet, this is the rough work that should be done in back of your mind. Fnet should be equals to root of Fc square plus Ft square. Now just fit the value. And get it done. I hope this is clear. Is it clear? Is it so? Is it possible by us to do this kind of questions? Are you sure? Are you? Great. Let's just wind it up the session over here. Yes, this is all about the kinetic energy and work energy theorem and its applications. From the next session, we are going to discuss about the potential energy, and from a very basic point of view of potential energy to their applications. Yes. So before you tune into that, please revise kinetic energy and work energy theorem, because it plays a very vital role to get the numericals done. Please do it. This will help us. Thank you. Have a good day. Take care. Bye bye.